So if I were to go to Sublime right here, I could type in 10101, and this obviously equals 21 and base 10. So to convert this, basically you're just going to start, I'll start with this 1 right here on the end. Normally we read this from right to left here, but basically it goes like this. You just say 1 times 16, because it's in the 16s column, plus 0 times 8, because that 0 is in the 8s column, plus 4 times 1, plus 0 times 2, plus 1 times 1, because that last one is in the 1s column. All right, oops, I didn't mean to say that. So if I were to add these up, 16 plus 0 plus 4 plus 0 plus 1 is equal to 21. Basically, that's how you convert from binary to decimal. So that's, in a sense, how a computer is able to make sense of decimal numbers that we can understand today. Now, why does a computer use the binary system? Why can't it use the decimal system? Well, basically because of something called information theory, which boils down all language to a sense of, I'll just write this here, information theory. It basically boils all language down to a series of trues and falses. So basically, if I have a true, if you ever heard of the game 20 Questions, which it can be played by a computer or sometimes a person, and they'll ask you 20 different questions about whatever you're thinking. And the goal, and usually they're successful, the goal is to be able to guess whatever you're thinking of in your mind in 20 questions. And you think, well, how is that possible? I could be thinking of anything in the world. How can you narrow it down to 20 questions? Well, basically because there's only so much to think about, and when you start multiplying, 2 to the 20th out, you can kind of see how quickly you can come up with many different themes. So it basically, everything boils down to a bit, and a bit is like, it's just a true or false. So a bit is a 1 if it's true, or a 0 if it's false. So then, eventually they string these bits together, and it makes what's known as a byte. So a byte would be 10100 or 01, sorry. Basically, like a number like this is a byte. Why is it a byte? Because it has 1, 2, 3, 4, 5, 6, 7, 8 numbers, ones or zero numbers strung together. That's a byte. That's all it is. It's just 8 bits, okay? And if I go to this website here, basically it kind of lays it out here for you. Talking about regular storage here, not this stuff necessarily, but just regular storage. 1 bit is equal to this binary digit here. 8 bits is 1 byte, and then if we're talking about what you guys typically measure for text documents, music, videos, video games, anything like that, we're talking about 1 kilobyte is 1,000 bytes, 1 megabyte is 1,000 kilobytes, 1 gig is 1,000 megs, and then basically you might have heard of terabyte. 1 terabyte is 1,000 gigabytes, and you probably haven't heard of these at all. In fact, if you look down here, this link is in the description, in the chapter. This GAP byte here, they're not even sure why this term was created, because nobody alive today will ever see a gigabyte hard drive. It's such a massive amount of memory that it's inconceivable to think that we would ever create something for at least a very long time. And we'll actually talk about why that won't, why we couldn't do something like that in a later chapter. That has more to do with computer engineering. But basically, that's just the idea. I wanted you just to have a basic concept of information theory. And again, I think I discuss more about this stuff inside the text, and it's definitely a good look if you haven't already to read over some of that. And then definitely click on the links that I provide, because they take you to some pretty interesting readings and stuff. All right, so let's just go into our code editor real quick, our PyCharm here. This is from the last tutorial. I'm just going to erase it though. And we're just going to go over some examples here. So I talked about before about data. We were talking about like just storing data and stuff like that. You can do that in the code, and here's how it's represented. Basically, in order to store anything, you need to use what's known as a variable. A variable can basically be any word in Python programming. So if I just, or a letter, for instance. So if I just went with X here, X is a variable. I don't have to do anything to declare it. You have to do that in many other languages, not in this one. All I have to do is type it. And then all I have to do is set it equal to something, because all variables should be set equal to something in programming, especially in Python, because you can't just initialize it. So I'm going to say x is equal to 5. And then if I go down here, I can say print x, and when I run this thing, you're going to see down here it prints out 5. Now, why didn't it just print out x or something like that? Well, it's because we have this variable here, and we know that the variable x is equal to 5. Simple enough, but just know that we're taking something on screen here, this 5, and we're able to store it in a variable for later use in the code. So anytime you save something on a computer, any of your files on a computer are basically stored in a type of variable, or a file output variable or something like that. And we can do this with a lot of other stuff too. I could, I could say x is equal to 20, and then y is equal to 30. You can have multiple variables, obviously, in the same code, and you can just print both of them out. Maybe, I'm just going to do it without the parentheses here. I'm going to say print x, and I'm going to say plus 20. Oops, sorry, y, or sorry, yeah, just like that, I think, right? Fuck. So if I print this out like this, I can say x, comma, and then quotations around this plus sign, comma, y. And if I were to run this here, it actually isn't going to give me like 50 or something like that. It's literally going to be able to write it out as 20 plus 30. That's just a different way of writing variables in the code. Again, if you saw that in the text, you'd kind of understand how that works there. And I don't have to just store numbers in variables. I can create the variable name. Again, I'm just making name or this variable name whatever I want it to be, and I can store in here, like Mr. Scanlon or something like that. I could store my name, and then down here in the code, I could say print name. Instead of having to write out print Mr. Scanlon, I can just write print name. And then when I run this, it's going to get ran. And again, maybe I don't want just my name there, but maybe I want many of my names. Now I can run this without having to worry about, setting this entire line of Mr. Scanlon's inside of here. I could just use the variable.